What is bidirectional recurrent neural network, BRNN? Bidirectional recurrent neural network, BRNN, recurrent neural network, RNN, and hybrid neural networks are all types of neural network architectures used in machine learning and deep learning for various sequence modeling tasks. Let's explore each of these architectures. 1. Recurrent neural network, RNN. Overview: RNNs are a type of neural network designed for processing sequential data. They are particularly useful for tasks where the order of the input data matters, such as natural language processing, time series analysis, and speech recognition. Structure: RNNs have recurrent connections that allow information to be passed from one step of the sequence to the next. Each step of the RNN processes an input and produces an output, while also maintaining a hidden state that captures information from previous steps. Applications: natural language processing, RNNs, can be used for tasks like language modeling, machine translation, and sentiment analysis. Time series prediction, RNNs, are effective for predicting future values in a time series, such as stock prices or weather data. Speech recognition, RNNs, can be used to convert spoken language into text. Challenges: traditional RNNs have issues with vanishing gradients, making it difficult to capture long-range dependencies in sequences. This limitation led to the development of more advanced RNN variants like LSTM, long short-term memory, and GRU, gated recurrent unit. 2. Bidirectional recurrent neural network, BRNN. Overview: A BRNN is an extension of the traditional RNN that processes input sequences in both forward and backward directions simultaneously. It was designed to capture dependencies from both past and future context. Structure: in a BRNN, the input sequence is fed into two separate RNNs. One processes the sequence from the beginning to the end, forward, and the other processes it in reverse, backward. The outputs of both RNNs are then combined at each time step. Applications: natural language processing, BRNNs, are useful for tasks that require understanding the context of words in both directions, such as named entity recognition and part-of-speech tagging. Speech recognition, BRNNs, can be used in automatic speech recognition systems to capture contextual information from both preceding and following phonemes. 3. Hybrid neural networks. Overview: hybrid neural networks refer to architectures that combine different types of neural network layers or components to leverage their respective strengths. These networks often integrate convolutional layers, from convolutional neural networks, CNNs, recurrent layers, from RNNs, and feed-forward layers, from traditional neural networks, in various ways. Structure: the specific structure of a hybrid neural network can vary widely depending on the problem at hand. For example, in a text-to-image generation task, you might combine a CNN for processing images with an RNN for generating text descriptions. Applications: computer vision. Hybrid networks are used in tasks like image captioning, where CNNs extract visual features from images and RNNs generate textual descriptions. Natural language processing. In tasks like machine translation, hybrid networks can combine CNNs for encoding the source sentence with RNNs for generating the target sentence. Benefits: hybrid networks allow for more flexibility in modeling complex relationships in data by leveraging the strengths of different neural network components. They are often used in tasks that involve multiple types of data, example, images and text, or require both short-term and long-term dependencies. In summary, RNNs are designed for sequential data. BRNNs enhance RNNs by processing sequences bidirectionally, and hybrid neural networks combine various neural network architectures to tackle complex problems effectively by leveraging the strengths of each component. The choice of which architecture to use depends on the specific task and the nature of the data being processed.